For the data types, usually it's all categorized by the size of the data that you try to capture using your network monitoring tool. Regardless it's IDS or IPS, they all will have the same characteristics from the point of view of the data size. One of the biggest data size that can be used is the full packet capture, or the FPC. Usually they go and call it PCAP file because it's a bit smaller than the full packet capturing, and it provides all the details of the data transmission from point A to point B. Every single log. It's like recording a phone call on the line or something like that. It actually also can be reduced later on to a PCAP or even a P-string data. But right now, the full packet capture is just every single detail, every single packet, and all the information available for a specific transaction or communications. So we call this sometimes the session data flow, which is a summary of the communication between two network devices. And this is what is a FPC data is. Other types that we can consider for the packet capture, some of them can be statistical data, just output statistics, the mean, the size, and so on, which can be generated over time. Something to notice whenever you use statistics. Statistics need some samples to run. They will not be able to be just popped up from one or two samples. It doesn't make any sense. So anytime we use statistic, it means that the traffic already gone. So the information will be usually a past result, a result for a past data that's already been sent. A lot of specialists think that statistical data is concurrent. Oh yes, it is, but it's actually a representation of something in the past. Sometimes in cybersecurity, we need the data here and now. So statistical data will be like a secondary analysis you can use. Other type of data capturing is a P-string data, which is usually most commonly used. It's just, imagine it's like a log between what happened on the network. It have some session information, and it's still bigger than just the log of the data. So the benefit here is much smaller and almost like a log, who was talking to who on which protocol. And it's usually written in human readable language, which is why they call it P-string. Data log, other type of data that you can get from the network, and it's usually the raw log files from your system, from your servers, from your machine, and as well as the switches, all the routers, firewalls, and VPN devices. All of them have some log data /var log. They have it there, so we can use all of data to make a better decision. Other type of data, which we call is the alert data, is usually created by some detection tool, including some feature. It's usually very small, just a pointer to a time of some data. And as an example here to see the comparison, if we have a full packet capture of 100% of the data of a size of 1 giga, usually the P-string will be only 4%. 4% of all of that, which will be only 40 megas. And the session data will be even less. It's like 0.01 of the data. And to see that visually, to get a better understanding, this is how much the relationship between the size. So if we have a full packet capture, we'll be capturing all this amount of data. If we're talking a P-string, it's much less, only 4%. Session even smaller, and the log will be just this small square rectangle right here. So why are we discussing that? Because the cost of storing all this activity is very crucial, where we will have all this hard disk, and we know the hard disk can fail with time. So you will have some type of backup, and the backup can also fail. So you have a backup of a backup, also a mechanism to change the hard disks. And how long it will take you to reach a specific packet if you're storing everything for full packet capturing. However, at the same time, if there's some problem happen and you need to go to a specific stream of communication or to bring it to the court or something like that, you will need the full packet capture for some reason. So it's usually an art and engineering part to decide which servers or which asset you will need to keep the full packet capture communication for it, and which one you will need only the p string or the session data at all. And it's up to the design. There's no single rule. It's about how experienced you are with this part. And from our point of view, from the data driven, we need to get really just enough data to make a good decision without going to the details. So we very rarely when we will go to the full packet capture, but we will be interested in the session, for example. P-string, not always, but session will be for sure, and the log will be much important. So whenever we build, we can communicate with the network security monitoring team, and we ask exactly what data we need for our analysis. And all of this data are connected by something called sensors, and the sensors usually can be categorized in 3 classes: collection only, something that just collects the data and stores the data out of it; half cycle, which means it has some capability of doing detection of some traffic; full cycle, it means it does collection, detection, and analysis, which is usually a bigger device, more costly to operate and so on, but have full operation. Even from the collection only, we can benefit to get the part of the data that we are really looking for. In this diagram, you can see how these 3 different collection from half cycle, full cycle, and collection only. The collection only, you can see the sensor and another server to store the data, and it just collects and send the data to a server here, because this sensor doesn't have any mechanism for detection or analysis. It just collects it and sends it somewhere. So whenever we have this scenario, we'll get the data from this server instead. In these 2 scenarios, the half cycle and full cycle, will have to get the information from the sensor itself. So we have to make sure that we have a correct access and access right to the sensor itself to collect the data and collect the logs or alerts. And if you have the analysis tool, you can even get the report out of it. So make sure whenever you build your data-driven cybersecurity that you have access to these devices on your network. Also, one of the terminologies that you can use in the network monitoring tool, ingress or egress collection, which means it's external placement or internal placement of the sensor. How it will affect us: if we have a device that will be reading data from the sensor, it's very hard to get it from out of the router. You will have to get your security team and your system administrator to put specific rule or specific path on the firewall and on the router to get you access to the sensor, and usually it will be in the DMZ or something like that. So it will require more work to do that. For the internal placement of the sensor, you don't have to put any internal for the internal router rules, because you might be in the same router side or the same subnet even, but make sure that you have a correct credentials to get this data from. A small quiz to show you how the relationship between the size of the stores that you need. So imagine if we have a traffic of 1 gigabit per second connection, and you have time of the day, how many hours you have, multiply by 24 hours, and you can get how many gigabits per second that you need to store. We divide it by 8 to get it by byte. We have around 10,000 gigabytes per day. Double that now, because you have 2 directions in and out. This is how much storage you will need to store activity only per 1 day. So from historical analysis and the event log and so on, the storage can grow very quickly. And right now, it's considered you can have at least minimum storage of 2 gigabytes daily. And the ideal will be 3 terabytes to store all data, which really very expensive to maintain, operate, and even to process all this data. Imagine how much your backup, the traffic for your backup system will be after 5 p.m. or like after work hours to back up all this data to another tape or something like that. It will take too long, and sometimes you might not have enough time to back up even your Exchange or mail server because of all this traffic on, and which makes the security expert just remove it from the backup, and they rely on the reliability of the hard disk. Now, talking about the ability of hard disk, you will be writing data 24/7 basically. Yeah. So now even the ability is compromised. So make sure what type of data we're gonna use. Make sure to just tell your network monitoring team to get you the sessions data. If you don't need the full packet capture, you don't need make them to collect that for you, because all of that session is in the background. And we have a lot of challenges here. First of all, there's no standards when and which data type we need to collect. And the art here to build the correct packet capturing and get the right data that you will need for your data-driven analysis later on. So it's not just a tool, it's an art more than it's a science or IT tool. Always keep in mind that if you want to imagine the network and the network traffic, it looks exactly like this sea wave that you can see. It comes and goes. You have the minimum, and sometimes you have a very big wave. So whenever you design your system, make sure that it's capable more than enough to hold the highest wave in this crazy sea of information. I will conclude here, and remember that network packets are often the main source of any cyber system, and there's always a data source and data collection. Remember, the vulnerability will be targeting your operating system all the time. And that's all for Module 4. Thank you so much.